Hello, campers. Welcome back. It's the very last day of camp. I hope you have learned a lot about SQL, but we're not done yet. Today, we're going to talk about nested and repeated data. I do see that there's some questions in chat. The Learn team is familiar. It sounds good. The Learn team is looking into the errors, so hopefully those will be resolved ASAP. And then the time for the exercises to be completed are midnight anywhere in the world, which is an actual time zone in like the middle of the Pacific. So if you're on the, depending on which side of the time zone you're on, you might have almost all of Saturday as well. So, and now I'm going to cover the chat and not look at it, because otherwise I will just answer questions the whole time and not actually do the things that I said I was going to do. And that's frustrating for everybody. But there was a really good question that I am going to address super quickly. What does this have to do with machine learning? Why do we care about SQL? Why do we care about databases as data scientists? Because I mentioned a couple times, if you're interested in really like building and maintaining databases, probably you should be looking for DBA or database administrator roles rather than data science roles. Although I have seen recently a couple of data science roles in title that were actually looking for database administrator, so be aware. And the reason is because if you are doing machine learning, you need data, and generally the data is going to be in a database somewhere, if you're lucky. If you're unlucky, it's in like some like weird format files on somebody's hard disk that they scraped from web pages in like 92, and like they're inconsistent character encodings and nothing's parsable. That's the nightmare scenario. The best scenario is that you have a beautifully formatted database to work with, and you want to get out the data that you're looking for. And also, at some point, once your models are being put into deployment, they're going to need to interact with data in the database. So when we did the BigQuery machine learning workshop, a big part of why BigQuery machine learning is a time saver for you as a data scientist is you don't have to go through all of the like rigmarole of building an API and serving your model, which can be useful sometimes, but you just sort of put it in your database and it's served from the database. And if you have to wait for somebody on your team who does have database access or does know SQL to go and get you the specific data you need every time you need data, that's a huge blocker. That's a pain in the butt. And most job postings do in my experience, I'm thinking about all the different conversations I've had with all of my friends in data science. Most jobs do sort of expect you to know SQL if you're going into a data science role. So that's why it's important for machine learning. My content, at least for last year, I've been more focused on sort of the professional skills that will help you in, your early career, that might be a little bit more difficult to get, data science-centric education around. So that's why. All right, let's jump right in. Today we are doing the Nested and Repeated Data Notebook, and if you're looking for the link to that, it's in the Kaggle Learn Advanced SQL course, and then it's the third one, Nested and Repeated Data. And we will do a little bonus lesson on writing efficient queries, but you don't have to do lesson 4 in order to get the certificate. So we'll do that a little bit later on. And if we click into the notebook, this is what you should see. So far, all of the data that we've worked with has been, except briefly in the VQML lesson, and I did tell you we would talk about it, and today is the day that we talk about it. All of the data that we've been looking at has been tabular, and it has been more specifically what's called tidy data. So the idea of tidy data is that you have your observations in rows. So here, observations are different animals. You have your variables in columns, and you have one value per column, right? And if you've worked a lot with databases, or spreadsheets, this seems like pretty intuitive. And the reason that that's a specific way of working with tabular data is because you could also have things like this. So this is an example of data that's not tidy. We have a hierarchical data structure inside our database. And just to show you what I mean by that, so this is from the data cleaning challenge a while ago. The link was in the notebook that I sent y'all. So tabular data, rows and columns. Hierarchical data has a tree structure to it. So you'll have sort of nodes that are parents, and then those parents can have children, and those children can have multiple children. And generally, the sort of like biggest possible node with all of the things you could have is defined in a schema, and that's going to be sort of the fields that you can expect, but you're not necessarily going to have all fields depending on the specific type of hierarchical data for each node. You'll also notice that we have here sort of like a little oh geez, what it's called? It's called keys, wowzers. So you have the sort of information about what the data is, and then the specific data that we're looking at, right? So this is sort of similar to the column names. So here we have the name, and the name is Robin. Here we have the name is Bunny. We know that these two nodes tell us the same sort of information. Here we can see species, hedgehog, species, rabbit. But you can also see that Robin the hedgehog, we have the owner and the address, and Bunny the rabbit, we don't have the owner and the address, but we do have the color, but we don't have that information for the hedgehog. So hierarchical data is a really common way of storing data, especially on the web. If you've worked much with JSON files, or you've interacted much with sending data to or getting data back from APIs, usually that will be in a JSON format. XML is also another hierarchical data format. I get the impression that was more popular in the past and is, sort of stepping down in popularity, and JSON is stepping up in popularity. So. Keys and values, sorry, that's the word I didn't remember. So Robin here is the value. Wow, little sip of tea. Okay, so you can store hierarchical data in cells in BigQuery. And this is, again, this seems to be more common when people are working with web data. So you have information about, some sort of event. The example data set that we have down here is the Google Analytics data set, where we have information on, and we'll talk about this more in a little bit, the visitor, the visit ID. So this is somebody doing something, and then we have all sorts of different information about different attributes that they have. So here we have a lot of information about the device that was used for the web visit. Here we have information on the total number of visits and hits and page views and so on that this visitor did. More information on the traffic source, so how they got there and sort of what links they clicked. And you could make a super duper wide table, but you wouldn't necessarily, even if you had a very wide table, be able to nest things. There's no way to say that like the total column is nested under the date column, right? That's not really how tables work. So that's why hierarchical data gets used. So looking at some of the syntax that we need in order to interact with the hierarchical data. So in BigQuery, these particular types of hierarchical structures in cells, so this could be a JSON file, or you could get it from XML. This one right here. These guys are called records. And I mentioned that there is the biggest possible sort of hierarchical structure you could have for, a node of your tree or a record will be stored in the schema. And you can see an example of this right here. So in this particular table, we have an ID, so just the ID of the, in this case, it looks like the ID of the pet, and then the age of the pet, and then the animal, so the type of animal that it is, the species, and then their toys, so the type of toy that it is, and then the name of the toy. So you might have a dog that has like a little squeaky ball that you call Squeaker or something, is sort of the idea there. And all of these are represented in the table schema, which we looked at in the very first lesson, so you can head back to this link and refresh your memory. So we have the first column is in integer called ID, so you can see, sure enough, those are integers. The second column is a name, and that's a string. Nullable here means that it can be empty and you won't get an error. The fourth column here is animal. You can see that's also a string, age is an integer. And then this fourth column here is a record. And inside the record, we have two fields. So we have the field name. So you can see here we have the key name. Here it has the value McFly. Here it has the value Fluffy. Here it has the value Eddie. And then we have the key type. Here that has the value Frisbee. Here it has the value Feather. Here it has the value Castle, right? So that's the way that the data is structured. And when you see a record in a data set for the first time, you can look at the schema and figure out what's actually in that record and what you can expect to be there. And if you want to query into that cell, the way that you can do that is that you can use the dot. So we would write our query as usual, right? So we're selecting from this particular data set. It's in the BigQuery Public Data Project, it's in the Pet Records data set, and it's in the Pets and Toys table. And then we're selecting name as pet name. So we're just taking the name column and then we're aliasing it to call it pet name. And you can see in our output column here, it's called pet name. And then we are looking into the toy column, so this toy column, and we're getting the toy.name, so we're getting the value of the name key for each row. And we're going to call that output toy name. And then we do the same thing with toy type. So basically we're reaching down into the hierarchical data structure, getting just the field that we want and putting that in a new column. This is a pretty simple data structure. It's pretty straightforward for us to, unzip it almost and put it into columns. And that's the sort of syntax that you would use even for more complex data structures. All right, you can also have repeated data. So this is another type of data that's not tidy, and this is more of I think it's more like of a space-saving measure in terms of your total database, the memory that you need to store your database. So in this example, we have different pets, and each pet can have multiple toys. So dog, the moon, you can see the pet ID is 1, and if we look at the pet ID in this table, we can see that it's 1, and look back and be like, okay, that's moon, moon is a dog. Moon has a frisbee, a bone, and a rope. The cat Ripley has a feather and a ball, and the fish Napoleon has a castle. And we could store this using 6. I can count. We could store this in a table using 6 rows. So we would have like moon, dog, frisbee, moon, dog, bone, moon, dog, rope. Or we could store it using a repeated data structure. So what a repeated data structure lets you do in BigQuery specifically is it lets you store I was going to say a one-dimensional array, but a one-dimensional array is a scalar. So it lets you store basically an array that has the same type of data in it repeated as many as you need, so you don't need different columns. So you could imagine, we've talked about like an example with an e-commerce data set. If you have the order that someone has and they have a bunch of items in their order, you could store each of the items in this repeated structure. And when you look in the schema for these, you can see that it looks pretty much the same until we get to this third attribute. Wow, until we get to this third attribute here, you can see these are all nullable. This one is repeated. So if we have more than one value of the same type, they all do have to be strings. We can't just like throw an integer in there for fun. You might could, but it would be coerced to a string? Possibly. Does SQL have static typing? That's a question for us to talk about later. I'm going to write that down. My intuition is that it does. I don't think it would be coerced to a string. Have static typing? Question mark. All right. And you can see it's an array, so it is an ordered list. And if we wanted to go from this repeated data structure into the long one where we had 6 rows, we could do that using this unnest function. So to just go through this query, let me zoom it up a little bit so you can see. We are selecting name as pet name. So from this column, we're getting the name. And we are also selecting toy type. And you can see if you look up here, there's no information called toy type. Where's that coming from? The toy type is actually coming from this part here underneath the from, where we're saying unnest toys and alias that as toy type. So we're taking this repeated data structure, we're converting it to a bunch of columns, and then we are getting those columns with our other column that we've created. I mean, it existed, we just re-aliased it. And you can see that it automatically associates Moon with Moon's toys, and Ripley with Ripley's toys, and Napoleon's with Napoleon's toy. So we don't have to do all that futzing by hand. The unnest function will do it. And then this is just a little, you can see Frisbee is first, bone is second, rope is third. Because of the way that BigQuery is shuffled for processing speed, you might sometimes get things in a different order. Yeah, we'll have to experiment. That seems like a good question to check out. All right, so we have nested data, we have repeated data. We can have both. We can have data that is both nested and repeated. So this would be maybe in our product example. You have a bunch of different products. They each belong to a different category. Somebody buys, a spoon from Homewares and a chocolate bar from grocery and a stuffed animal from toys. So you have different types of information on each of these items, but they're of the same type. So we can say that in the schema field, we can see that you can have repeated data here, but it still has to follow this schema. So we still are going to be looking for, in each repetition, up to 2 fields, one field called name, one field called type. And if we wanted to get that information, we need to both unnest it and also sort of dig down into it like we did with the regular hierarchical information. So here we're selecting name as pet name. We've done that before. Here we're selecting t.name as toy name. So name is coming from here. That's the key name. You wouldn't be able to replace this with something else that's specified in the schema. Type is coming from here. That's the key. And the t dot here, you can see if we look here, there's no column called T. T is coming from us unnesting it. So we're actually doing 2 things here. We're taking this hierarchical structure, we're unnesting it, and then once we've unnested it, we're sort of going through and grabbing the different parts under the hierarchy. So that's a lot to wrap your head around. Let's work through some examples. So I'm going to start a new kernel. kernel.com/kernels. There we go. New notebook. Python, yes. Notebook, yes. Create. And then it was the Google Analytics dataset I believe we were using. We'll zoom out a tiny bit. And you can see that's a BigQuery dataset. Pretty sure this is the right one. If it's not, we'll find out. And then again, we have all the sort of the setup that we've been using all along, the same code. We went through this in detail on the first day. I think I've said that every day. But I don't know, maybe you only watched one of the videos. That's fine. Oh, that's right. This is a new feature. This just launched. So now, if you are looking at a public data set, sorry, I'm very excited about this. If you're looking at a public data set and you see something with a blue underline and you click on it, you can see other references to that specific thing. So you can see this one is, this is where it is referenced in the same notebook, and these are the line numbers. But I believe we can also see, you can also see if other people have done the same thing. So if people have used the same sort of like code snippet, you can see that, and then you can go, I'll open that link in a new tab. You can go check out their notebooks and see what they did and be like, oh, cool, I see what you're doing here. So just a little fun extra thing that we just added that's public now. Sorry, I got distracted. It's cool. I think it's cool, okay? And hopefully that'll be really helpful and help you find people who are working on problems that are similar to what you're working on. All right, so we should now, there we go. We can see the information about the data set. We talked a little bit about this earlier, and we can see, sure enough, some of it is, some of it is nested. You can see this is nested. You can see, this is nested, this is nested. You can also see that some of them have square brackets around them. And if we look up here, you can see, just as an example, that, so it's not behind my head, repeated data has square brackets around it. So even without looking at the schema, we can look at this and be like, oh, hey, we expect the column custom dimensions to be repeated. And of course, you can be repeated 0 or 1 time, so I don't think we have any repetition examples right in here. But we could expect repeated data from this column, and if we're going to query it, we're probably going to want to unnest it first. Whereas, I don't know why using mouses is hard. Whereas for these columns here, you can see they don't have square brackets, so we know they're probably not repeated. No, we know for a fact that they're not repeated. So just a little visual cue to help you suss out what the difference is. All right, let's work through, actually, let's first look at the schema and then work through a query. So, remember we talked about the table.schema, so we've created our table object up here where we got table from a table reference that referenced the dataset reference, that referenced the client. It's all very object-oriented. And we can use the table.schema to look at the different schemas. And you can see here we have a number. So this is a reference to the column. So we are looking at, if we start from, why can't I scroll good? 1, 2, 3, 4, 5. Nope, we start from 0. 0. 1, 2, 3, 4, 5. That's right, because it's in Python. So we're looking at the 5th column, which is actually the 6th column, which is totals. And then here we're looking at the 7th column, which is actually the 8th column, called device. And so you can see if we look at the schema record for this column, it's called totals, it's a record, it's nullable, so it's not repeated. And then we're expecting a number of schema fields. And I know that the line spacing on this is a little hard to read. One called visits, that's an integer. One called hits, that's an integer. One called page views, also an integer. Time on site, bounces, transactions, transaction revenue. I'm trying to see if any of these are nested inside each other. I don't think they are. New visits, screen views, unique screen views, time on screen, total transaction revenue, and then session quality, dimension, demography. I don't know what the dim would be. And then for the device column, we have information on, you can see it's nullable, it's not repeated, browser version, operating system version, and so on and so forth. Also, any of these in here could be repeated. Yeah, so you can get pretty complex with your data structures. Should you? You can, though, if you need that. All right. So now that we're sort of a little bit more comfortable with the schema, let's check out a query. So here's our first query, and you can see that we are querying from this data set. So BigQuery public data, Google Analytics sample, GA sessions 2017-08-01. And I believe this particular data set, there is a different table for each date in the date range that they're looking at. And we are selecting the device.browser. So we're looking in the device column here, and then we're getting information from the browser field, and we are calling that device browser, and then we are looking in the totals column, this one, and we are getting the transactions. It's in here somewhere. There we go. And we're getting the transactions. Oh, I can't. Why is mouse hard? Here we go. This one right here, transactions. And we are getting the sum of the transactions. So transactions is an integer. It's the number of transactions that person made on that particular visit. And because we are doing an aggregate function, we need to also aggregate or group by all of our other variables that we select. And you can see, sure enough, we are grouping by device browser, and then we're sorting our returned results. So what we would expect to see here is two columns, because we've selected two columns, one called device browser, one called total transactions, where device browser has a string that is the name of the device browser. Total transactions is an integer. And then they should be sorted high to low. So let's see if that's right. Well, dang, it looks like it is, right? That's nice. So you can see we had 45 transactions on Chrome, 3 on Safari, 1 on Firefox, none on Internet Explorer, and none on UC Browser. Don't even know what UC Browser is for this particular data set on this particular day. So the only thing that should be new here, if you've been following along, is that we are looking into each of these fields using this dot notation. All right, but what if we had repeated data, you ask? Good question. Oh my God. Maybe I need a new mouse. Maybe my little spring guy is not happy. I'm it on the mouse. It's not that my finger's not working great this morning. All right. I'm going to try and wrap this up in 3 minutes so I can get to everybody's questions and actually look at the chat. Okay, so if we have, and I don't think we actually looked at the schema for hits, did we? I don't think we did. But there is a little bit more information here. Actually, let's look at the schema for hits. I think that would be helpful for us. So before we actually run this query, table.sch. Thank you. And then we are looking for the schema for hits, which is the all right, it's right there. It is the 1, 2, 3, nope, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is GeoNetworks. 10, it's the 10th column, actually the 11th column. So we should get the information on the hits here. Nope, we did not. Okay, there we go. So we can see, looking at the schema, that hits is a has a pretty, complex schema, lots of things going on here. We can see that it's a record, so we expect it to be a nested data structure. We can see that it's repeated, which we saw earlier because it has square brackets around it. Square brackets are for repeated data. And then the specific things that we're looking at here are hits.page.page path. So if we look at hit number, various types of information. I'm looking for a page here. There we go. So if we look at page here, we can see that the data type of page isn't like Boolean or string or something else. It's actually record. So we have a record inside a record. So we have sort of two layers here in the structure. I mean, that's what makes it hierarchical, that you can have records inside other records. It's nullable, so this one isn't going to be repeated. And then inside this page record, we have page path, we have host name, we have page title, search keyword, search category, page path level 1, a bunch of different information. And in order to get to the information inside the page record, what we would do is we'd say, okay, look in the hits column. Within hits, look at page, so hits.page. Within page, look at whatever it is that you're looking at, page title. The specific piece of information that you want. So that's why we have two, boop, boop. That's why we have two periods here. This is saying, look in the hits column, then look in the page record, then look at the value for page path. Save that as path. It's not repeated, so we should only... No, so the whole data structure can be repeated. So if someone had multiple hits, we'll get one row for each hit, but within each hit, there was only one page path, which makes sense because a hit is a view of a single URL endpoint. And then we are also looking at the number of hits as counts. Okay, so we're getting all of this information, and then we are counting, and we're doing an aggregation, so we're going to have to group by or aggregate all of the columns that we get, and we can see, oh, sure enough, here we are. We're grouping by path, so we're going to get information on the number of hits per path. But remember, the hits field is, or the hits column is repeated. So in order to make sure that we can get that information out, we need to unnest it first. So we're unnesting hits. We're just calling it hits again to make our lives easier. And this, I believe, happens, oh God, I'm not entirely sure where that happens in the execution order. Pretty early, the unnesting happens. And then we're doing a little bit of filtering of our results. So we're only doing hits that are hits on a specific page. So there's a field in the hits column called page, and we're making sure that those are the only ones we get. No, there's a field in the hits column called type, and we're only looking for ones that match page. And you'll notice this is a string, so we're looking for strings that match the specific string, so it is in double quotes. And then we're also looking for hits.hit number equals 1. So the first hit that they make, the first hit that each visitor makes on a specific visit. Sorry, there's a lot going on in this query. And then we're grouping by path, and then we're ordering by counts. So our expected output here, we're going to have two columns, one for path, one for counts, where we have the total number of hits per path, where the path is the first path that a visitor on a specific visit landed on the website on landing page. Basically, we're getting information on the landing page, and we expect it to be sorted by counts, starting with the highest number. So let's see if that's what we get. It is! Haha! Perhaps not super surprisingly, it looks like the most common landing page is home, with 1,257 sessions started. And then Google redesign, shop by brand, YouTube, 587. And then Google redesign, apparel, men's t-shirts, 117. I guess a lot of people wanted to buy men's t-shirts. And then signin.html, and then basket.html. So in this query, we are both unnesting nested data and also going into hierarchical data, so records, and going down multiple levels in the hierarchy. So that's how you do that. And now let's turn to the chat for questions. Did pretty good. 3 minutes over. I'm trying to do the content in the first half hour and then questions in the second half hour. So if you just want to watch the first half hour, you can. Thanks 1342 says, just watch your PyCon presentation. Great job. Thank you. I am very proud of that one. It's about why you shouldn't use deep learning. And I think it's when not to use deep learning, I think is the talk title. It's on YouTube somewhere on the PyCon channel. Bubble Ride says, is it planned to store competition data sets in GCP BQ that you can access through BigQuery? I mean, Kaggle is on GCP, so I think they technically are already. But your question is would you be able to query it as a Kaggle user through BigQuery? I don't know. I will say I don't spend a lot of time on competitions. Mostly I'm working on other parts of the site. So, shrug. Bubblebright says, one thing I always disliked about SQL, no syntax highlighting when wrapping it in string in another language. Yeah, that is true. So Bubblebright is talking about, because we are writing this query in Python and then sending it to SQL, we don't get the nice, like, select is one color and count is one color and, like, as is a different color, because that's a SQL reserved word. So yeah, that is unfortunately frustrating. Oh, God, I'm glad you liked my PyCon talk. Thank you. I'm going to scroll back up so I'm seeing folks' questions from a little bit earlier. Akash says, do we get the certificates as soon as we finish? Nope. There will be a bit of a delay. And actually probably will be a fairly long delay, because this weekend is a long weekend in the United States, so I won't be working during it. I'm also moving house, so I've got lots going on. But yes, you will get them. Scout's honor. I was a scout too, so that does make it means something. Is JSON format data in a cell hierarchical? JJ asks. Yes, hopefully I answered that question a little more recently, before now. T. Isabel says, I recently talked to someone who needed to create a database of car assembly line malfunctions. They needed to be classified according to the area machine part that malfunctioned. Sounds hierarchical. It could be. I think the way that I would design that, and I will say I've read like one book on database design, because I did some of it in my graduate work. I think the way that I would design that is that I would keep it tabular and have like car part malfunction, unless a part can have multiple malfunctions, in which case I would probably nest or use repeated data for the malfunctions information, assuming that the thing that you are most interested in is whether a part malfunctioned or not, and not whether the and not the nature of each of the malfunctions. If you're more interested in the nature of each of the malfunctions, maybe put them as separate rows. Like, you can store the same data a lot of different ways, right? So there's no wrong answer as long as it's not super duper duper big and hard to query. Questions. How to enter data into this table? So with your, you can see that I don't have BigQuery enabled right now. With the public BigQuery integration, you don't have write access to BigQuery. If you wanted to write data to a table on BigQuery, there's actually another video on the channel that might still be unlisted. I need to make that public, on how to add data to BigQuery using GCP. But you do need to set up an account for that. So, Sanyam says, how to check if we have completed all the exercise or is some remaining? Probably the easiest way is go to kaggle.com/me. Me will always direct to your account. So even though you type in the same URL, you're not going to go to my account. Kernels. Oh, that's really, first thing, spell kernels right. And you can see here I have all of the kernels I've ever written on this account. There's 48. And you can see here I have the exercise, joins and unions, and you can click into that and just like check and make sure that you did all the exercises. So that's probably the easiest way. Good question. Raymond says, can the repeated data be treated as a list in Python? Yes, but not necessarily for the purposes. Yes, that's the answer. Assuming that Python lists are similar to R lists, definitely in R, JSON data you would want to treat as a list. If you're working with sort of structured web data like that, I probably wouldn't use R actually, because of the way that it indexes everything, which can be a little bit of a memory problem if you're working with super, super, super big hierarchical data. It's also, I mean, the concept of, I don't know that that's true. I don't know that it's true that the concept of data frame was developed for R, but the fundamental, like, data frames as a data structure are like native to R. They are fundamental to how the language works, and indexing into things is fundamental to how the language works. So tabular data in R are just like peanut butter jelly. They go together fantastic. Other types of data in R, your mileage may vary. It depends. Just how tabular data in Python are, they're like peanut butter and bananas. They're some people's thing. I really like peanut butter and bananas. All right, let's see. Other questions. Oh, here we go. Mizan? Sorry, I'm probably not saying that correctly. Said you can get data from a hierarchical data structure or nested data structure in SQL into a list in Python. When executing the query, you can use the inbuilt .list function instead of the .toDataFrame method. Oh, that's really handy. Thank you for sharing. Quark says, is this BigQuery specific, or can we use this on, say, Redshift? I have not used Redshift. Let's find out. Nope. Oh, sorry. That was a mistake. Some data are hierarchical. Let's see. No, sorry. I keep typing it wrong. I'm sorry, guys. I'm dyslexic. I'm really not trying to do that. Nested data field red, SHIFT. Well, that wasn't it either. Nested data. Yes. I don't know that you can have it in a table, though. Interesting. Creating an external table that contains nested data, orders array. Okay, yes, but it's going to be called something different, it looks like. Good question. Sorry for typing bad. Tajosh says, what will happen if you try to store nested and repeated data in a pandas data frame format? I don't know as much about pandas. In R, each column can be a different data type, and one of the data types that it can be are lists. So if you tried to do it in R, you would get a data frame where the column contained a list, and lists can be listed within other lists. They're hierarchical. So that's what you would get in R. And I'm assuming you get something similar in pandas because pandas is based on R. Yeah, if somebody knows, please feel free to hop in. Sentha Mizan says you'll get the syntax highlighting if you use a SQL IDE. Yes, that's true. Also, if you're in the GCP console, you should also get syntax highlighting, but I like to work from Python, so. Other things. Time to submit midnight anywhere on Earth tomorrow. I think I mentioned that. Happy birthday, Bubble, right? So the reason that we've added the ability to interact with BigQuery is so that if you want to write BigQuery data sets or your personal BigQuery data sets or work with private BigQuery data through kernels, you can do that. That's all that's about. All right. Jiltine says, how can we know if they do the exercises properly? This exercise isn't have an automatic check. Oh, yeah. Sorry. That was written better. I'm just not good at... I am good at reading. I'm just... sometimes I make mistakes, and that's normal. If you've done it, we'll be able to figure it out. Yeah, we're still working on ironing out a few kinks with the progress tracker, and we know that it's a problem and it's frustrating, and it is also frustrating to me and to us. So it's a high priority. We're working on fixing that. But even if the progress tracker doesn't say that it's done, if you've done it, we'll figure it out. Akash says, do we need to make them public? You do not need to make them public. We will be using SQL. Well, I'll be using SQL. Jessica says, what is unnest? So unnest is the SQL function that you use to take repeated data structures and take each repetition and turn it into a new row. Raymond says, can images be stored as blobs or other data types? Ooh, I haven't worked a whole bunch with images. I think the way that I've seen images in databases previously is that the images are stored somewhere else, maybe as blobs, and that the database has links to the images rather than the images themselves. Bubble Red says, Dask is better than pandas. All tools are good for something. Anjali says, is this course a continuation of the intro to SQL? Yes, this is the advanced SQL. So fancy. Quarky says, so talking about what can be in the columns, in Python it can be an object, which is pretty much any of the normal Python types. So yes, it sounds like it could be a list. Raghavendra says, how many levels of hierarchical can BigQuery access? So as many as are in the data set, and I don't think there's I think there's a practical limit to the number of hierarchical levels you can have, but I don't think there's a technical limit to them that I know of. Yeah, I mean, if you have a really, really huge hierarchical data set inside your SQL data set, probably you want to use, because there's types of SQL that are for hierarchical data, and if you got a big old rich data set that's hierarchical, you probably want to be using a different flavor of SQL rather than a tabular version. Just spilled tea all over myself. Fortunately, I think it's all out of frame. Question. Petra says, just dropping by to say thanks. You're welcome. Thank you for joining. I'm glad you find it helpful. Jessica says, will there be other courses on SQL? So we've done 3. We probably won't do any more in the near future. I mean, never say never, who knows? But I at least have other things that I want to talk about. So, maybe. Anjali says, is it okay if I start late? Yeah, of course. The materials will be available. The certificate was specifically for the SQL summer camp, but it's actually the first certificate we've done. So, we'll see how it goes. All right, let's head to the forums. Learn forum. There we go. So, question. I tried to submit the following query. Excuse me. James said, are you going to send out an email for the optional lesson? Yes. I'm still trying to figure out if I want to do the live stream for that tomorrow or next week, because I do want to do my usual live coding live stream. It'll be in the email. I will decide by noon Pacific today, and then you will know soon. I've got a lot going on right now, so I'm trying to make sure it's balanced. And just a tip about questions in the forums. When you are writing a big block of code or something, if you highlight it and then click on the insert code block, it will automatically provide the, just copy and paste. It will automatically provide the code appropriate formatting, and it's significantly easier to read. So you can see that for a block, you do 3 backticks. Those aren't quotes, those are backticks. For a little bit, you do 2 backticks, and then when you preview, it looks nice. And then you don't get the thing where Markdown is parsing your code as Markdown, and then you get the weird italic sort of thing. So just a pro tip. But we can still read this and answer question, no problem. So they don't have a valid query. This isn't a valid query. Here is the correct one. Let's see. So they are, so it looks like this is probably committer underscore name, and they're doing the counts from the data set. So far this looks okay. And then they're extracting the year, and they want it to be equal to 2016, and they're grouping by committer name, which is good because you're using an aggregate function, so you also need to group by. And then they're ordering by. Okay, and they said that it wasn't a valid query. And then the valid query, it looks like, is greater than or equal 2016-0101 and less than 2017-0101 dot date. Interesting. So the way that we're doing the automated question checking means that it's a little bit fussy about the specific syntax. So I would try moving this and onto the same line as where commit date, because I think you should be getting the correct information out with this, but our question checker is specifically looking for this syntax, is my guess. I would have to play around with it a little bit more to make sure that that's the case. So, question. Bubble Ride says, can I define unique key in BigQuery to avoid double entries? Or how to avoid double entries when you insert a bunch of data files? Oh, I don't know. Yeah, I tend to write more queries to get data out than put data in. And I definitely don't remove data. For sure I don't do that. Yeah, that sounds like a good question. I would, if you have BigQuery specific questions, I would put them on Stack Overflow and I would tag them BigQuery because the BigQuery team is pretty active on Stack Overflow and that's the best way to reach them for questions. Akash says, we only have to finish all the exercises sent in the email to get the certificate, right? Correct. Jagdeep says, can we connect BigQuery datasets in Google Colab as well as in Jupyter Notebooks? So Jupyter Notebooks, you definitely can. The thing that Kaggle does is that we handle a lot of the authentication automatically for you. If you're running BigQuery locally through Notebooks, you have to do a little bit more of the authentication. I don't know if Colab has an integration or not. It's actually been a while since I've used Colab. I should check in on them and see what they're up to these days. But yes, you definitely can connect from basic Jupyter. Pedro says, can we expect more courses with certification from Kaggle in the future? The future is a mystery, even to me. I don't know. I think it would be nice. Yeah, I think it would be nice. That's my answer. Raghavendra says, will using the same array and struct features work in BigQuery if I'm using Avro instead of JSONs? I don't know what Avro is. If you make me Google something and it's bad, I'm never going to forgive you. Oh, it's fine. Apache Avro is a data serialization system. Ooh. I mean, if it's serialized to binary, probably it won't work. Very possible. So JSON is stored as text. Serialization stores things in binary, and you need to be able to sort of like retrace your steps to unzip the binary file and get back to the file that you need. So this seems complex. I also don't see SQL in their little list of APIs here. So possibly, but it seems hard. That's my answer. Isabel says, Rachel, I was getting confused about the order of execution when we had multiple joins in a query. I've seen people use parentheses to make the queries legible / determine order. How would I do this in BigQuery? That is a good question. BigQuery force order of execution joins. It is possible. So BigQuery, like the thing about BigQuery is that it's really well optimized, right? So it is possible that it determines the order for you. Let's see. Outermost query when you use order by. Optimize your join patterns. Okay. Start with the largest table. When creating a query by using join, consider the order in which you're merging the data. The standard SQL query optimizer can determine which table should be on which side of the join, but it is still recommended to order your joined tables appropriately. The best practice is to place the largest table first, followed by the smallest, and then by decreasing size. When you have a large table as the left side of a join and a small one as the right side of a join, a broadcast join is created. A broadcast join sends all the data in the smaller table to each slot that processes the larger table. It is advisable to perform the broadcast join first. So that's the recommended order. I don't know about forcing the execution order using parentheses. I have also seen that. I don't know about BigQuery. Brian says, do you have any tips on how to learn Java? Not really. Not a big fan of Java. I just had sort of like a not super amazing experience in college with Java, so now I'm like, you remind me of that one time I wasn't happy. All right. Quirky, so talking about the Avro file, row-wise serialized, useful for sending over the wire. Oh, I can see that. Definitely it'll be, serialization makes data more compact. But yeah, serialized data that hasn't been unserialized in SQL seems like it could be a huge headache. I for sure don't think you'd be able to maintain the hierarchical structure. I think you'd probably just put like your serialized, output in a cell. I don't know. That seems like you'd be opening up yourself up for some like pretty big security risks there if you're just automatically unserializing something every time you make a query, and if someone like injects a nasty thing that's been serialized using your format. I don't know. Like, again, not a database administrator, but it just it feels like a bad idea. It feels like there's smells like something I probably would choose not to do given the option. Koshiki says, completed everything. Congrats. Everybody will get their certificate in sort of like a big batch in the future. Certainly not before the end of this week. So that's why there's a cutoff date, because I only run the query once. It's going to be a big one. All right, let's head back to the forums. Oh, maybe I wasn't on the forums here. /learn forum. There we go. All right. Joins and unions, question 3 and 4. So this is from yesterday. Question regarding extract date. Where do we have to use extract and where can we drop it? Extract is not used in question 3 and is used in question 4. Why? So I'm guessing that the reason that it is not used in question 3 and is used in question 4 is because here you are doing a comparison, and date comparisons on strings that are in the order where the date is last, like the month is first and the day is last, can be done alphabetically, right? Because just like in alphabetical order, 1988 0101 is less than 1999 0101, whereas extract date from creation date. It could also be that creation date is a timestamp, maybe? I don't know. It could also just be a style thing and that they both work. I have seen a lot of variation in when people do and don't use extract in different queries, so maybe it will work either way. Yeah. Raghavendra says Avro is the preferred format for loading data into BigQuery. Loading Avro files has the following advantages over CSV and JSON. I'm assuming the advantages are going to be that it is faster because they are smaller, because they are serialized. Mockingbird says, is SQL ML necessary exercise for the certificate? Yes. Yeah, so the question was more about having one one column that has a serialized format in it in an otherwise unserialized table. And I just, I don't know, maybe that is a good idea and I'm just wrong about it. All right. Exercise joins and unions. The exercise is empty. Oh, okay. So it looks like the solution there was just to delete the notebook and then refork it. All right. Completion of big QML. How will we find out if the exercise has been completed correctly? Yeah, yeah. I'm gonna write a query. And it's gonna be a big one, so I prefer to only run it once. All right. So Pedro says, do you like this format of the series being spaced in time? I think it's nice to give people a chance to finish and catch up and join as we go along. So I think that's nice. Yeah, I think I like it. Hopefully you guys do. I'll also be sending out sort of an end survey along with the information on the live stream for the bonus lesson. So I'll be looking forward to hearing your guys' feedback. All right. It is 10:01, so time to wrap up the live stream for the very last day. Finishing the exercises by midnight anywhere on Earth tomorrow, which is August 30th, Friday. Good luck. I'll be in the forums today answering questions. Keep an eye on things. I hope you guys have had fun at camp, and keep an eye out for that email with the information about the bonus live stream and the exit survey. All right. Thank you much for joining, guys. I hope you had fun and learned a lot about SQL, and I will see you all on Kaggle. See you there. Bye.